Now guys, still more calculations under motion, under gravity. Now for this question we have tonight, they are saying that a stone is dropped from the top of a tower 70 meters high. At the same time, another stone is thrown vertically upwards with a speed of 25 meters per second. Full stop. At what distance from the bottom and after how much time do the two stones cross each other? Now, I'm going to sketch that maybe this is the tower and this is the bottom. So they have said the distance from the top of the tower to the bottom is 7 meters. But I do not know at what distance these two stones cross each other. Now let me let maybe H1 to be the distance from the bottom. And U1 to be the speed of the stone from the bottom. Then also H2 is the distance or the height moved by the dropped stone. And U2 is its initial velocity. So when we try to sketch this on that diagram of ours, we are saying the distance from the ground up to where they cross is H1, and then the distance from the top up to where they are crossing, we have called it H2, and we are saying this stone is setting off with a velocity U1 that was given in the question as 25 meters per second. And then this one is being dropped from rest, then UT is 0. Now from interpretation of the question, this tells me that H1 plus H2 should give me 70 meters. But how do I get height? We using the equation S is equal to UT plus a half AT squared, which becomes for the dropping stone, it is going to become H2 is equal to U2 T plus a half GT squared. But we say since this stone is being dropped from rest, then this tells us that H is equal to U is 0, so all of this becomes 0. This is a half times 9.81 T squared. So that is the value of what? That is the value of H. Now, for the stone thrown upwards, we are also coming to look at for the stone thrown upwards. H1 is equal to U1T plus minus a half gt squared. Why are we putting a half? Because for upward motion, g is negative. Okay? G is negative. Now, why are we using the same time? The fact that this stone is thrown at the same time this one is dropped, meaning at the time of crossing, they have all used it at the same time. It means at the point of crossing, they have all used it the same time. Therefore, our h1 here is equal to 25t minus a half times t squared. But we know that h1 plus h2 should give us 70, because in the two expressions the only unknown is t. So we come and add them. This gives me, get my calculator here. This, when we compute finally, 9.81 divided by 2, here we get 4.95t squared. So let us add, this is 25t minus 4.95t squared plus this one, which is also 4.95 t squared, but this is the total height of the tower, which is equal to 70. Now we see this lying with that. Therefore, 25t is equal to 70. So we get 70 divided by 25, and the time it gives us is 2 seconds, 2.8 seconds. So this is the time taken for the two stones to cross. Then also the distance from the bottom, we say it is h1. Now distance from the bottom here, distance from the bottom up to the point of crossing, up to the point of crossing, the point of crossing is h1, which is equal to 25 times t minus 4.905 t squared. But the good news is that we know the value of t. We know the value of t. So we substitute for t and we get that height. So this is 25 times 2.8 minus 4.905 times 2.8 squared. So this height is 3.54 meters. This is the height above the ground where the two stones cross each other. I say that when we throw this stone at the same time the other one is dropped, it means that at the point of crossing, these stones have used the same time. However, they have covered different distances simply because the stone from up was undergoing free fall. This one was being projected upwards with an initial velocity that had been given in the question. So please, when you have such a question, settle down, interpret it, and then look at the equations of motion that can work for you. Thank you.